Pythagorean theorem is what's on the slate today. How can we use side lengths to determine whether a triangle is acute, right, or obtuse? Use the Pythagorean theorem and its converse to show problems, to solve problems, pardon me. Use the Pythagorean theorem inequalities to classify triangles. Did you know that? Did you know you can use the Pythagorean theorem to classify triangles?
Nope, not at all.
Well, you will today. All right? Then we'll talk about the Pythagorean theorem, what in the heck is a hypotenuse, and a Pythagorean triple.
What is the biggest pencil in the world?
What's the Pythagorean triple, right? We're going to get to it. All right. Check it out, guys. I know this is how all of you think of the Pythagorean theorem. A squared plus b squared equals c squared. Do not write this down. Just real quick, a recap of it. Probably the most famous mathematical relationship. As a matter of fact, first semester, teachers had to do all this training. They brought in some lady from somewhere, okay? And she was like, I taught science for 27 years in this state, and now I've been doing this for another 15. Anyway, I don't know anything about math. Can't remember nothing except a squared plus b squared equals c squared. Right? She was talking about the Pythagorean theorem, which she remembered back before there were calculators in classrooms. So, that's something you're going to remember. The problem with the Pythagorean theorem that I've experienced is this. You kids tend to forget what side is A, what side is B, and what side is C. Okay? So when we think of the Pythagorean theorem in here, I do not want you to think of it in terms of a squared, b squared, and c squared. Instead, I want you to think of it in terms of leg squared plus leg squared equals hypotenuse squared. Okay? So when you think of the Pythagorean theorem, it's leg squared plus leg squared equals hypotenuse squared. Okay? You can identify the hypotenuse. You go from the right angle in the triangle and go directly across. The side that is across from the right angle is the hypotenuse. The other two sides are the legs. Right? You can. The reason we do this is because not only does it apply with the Pythagorean theorem, but it'll also be helpful to us when we start our trig ratios tomorrow. Okay? Trigonometry is based on our first step for both the Pythagorean theorem and in trigonometry is to identify the hypotenuse. You've got to have the hypotenuse to work out those problems. Okay? So the first thing you'll hear me say it again and again today. What's the first thing I do? Identify the hypotenuse. Find the hypotenuse. Everybody with me? Okay? All right. Here we go. First up, 2, 6, and x. What's the first thing I do?
Find the right angle.
Find the right angle, then what?
The hypotenuse.
Then from there, go across and find the hypotenuse, right? Okay, my hypotenuse. Right? This helps me out because it will tell me how to fill out my Pythagorean theorem. 2 squared plus 6 squared equals x squared because x is the hypotenuse, right? Everybody with me? Okay? Since x is hypotenuse, I can just fill it out from there. The leg squared plus the other leg squared equals hypotenuse squared. 2 squared plus 6 squared is x squared. Let's see here. 2 times 2 is 4. 6 times 6 is 36. 4 plus 36 is 40. Right? Then I get 40 equals x squared. Because it's hypotenuse squared. Right? You hear me? Okay? I simplify this equation by taking the square root of both sides. Not dividing, but taking the square root. Right? 40 equals x squared. I'll take the square root of the left side of the equation, then the square root of the right side of the equation. That would leave me with the square root of 40 equals x. Type that into your calculator. I bet it simplifies to 2 times the square root of 10. Okay? Which is simple radical form. You can leave it at that. Okay? Everybody with me? Okay? Hopefully so. Then I give you something like this. So let's go over this again. What's the first step that I always do? Find the hypotenuse. Not find the x. Okay? It's not find the x. Because the x doesn't necessarily have to be the hypotenuse, right? You get that? Like problem 2 today on the classwork. Got a newsflash for you. X is not the hypotenuse. Alright? So it's going to change. You're not just going to solve the hypotenuse every single time here. Alright? Here's my hypotenuse, which means the other two sides of the triangle are legs. So if I plug this into my Pythagorean theorem, I get leg squared, x minus 2 squared, plus leg squared, 4 squared, equals x squared. Okay? Whenever I've got a binomial, x minus 2 squared. Okay? Guys, you learned this. Again, it didn't matter who taught you last year. You learned this one of two ways. You either learn the FOIL method, first outside, inside, last, or you learn the box method. Let's talk about FOIL first. X minus 2 times x minus 2. Multiply the first expressions, you get x squared. Multiply the outside expressions, you get negative 2x. Multiply the inside expressions, you get negative 2x. Multiply the last expressions, you get plus 4. If you combine that, you get x squared minus 4x plus 4. How many people remember that one? Okay, most of you probably learned it like this. X minus 2 squared. X minus 2 creates your box. X minus 2. Right? Solve the boxes. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is another negative 2x. Negative 2 times negative 2 is 4. Combined are like terms. Hot dog, I get the same expression. Okay? It's been a year, probably, for most of you, since you've done any of this. Okay? So I'll put that on there today. I think you may see it a little bit at a time from here out. It does two things for the state. Number one, it sees if you know what the heck the Pythagorean theorem is. Number two, it basically retests you on this, right? Because you got to remember how to do this, and this is from last year. So they're basically seeing if you can do all this again, okay? We don't want you to forget things and never use them again. So that's what they're getting at here, okay? When I'm solving this out here, all right, here's what they do. They're going to combine like terms, so 4 and 16 become 20, right? They subtract x squared from both sides. So if I subtract x squared from both sides, this becomes 0. I get negative 4x plus 20 equals 0. Here's how they do it. They add 4x to both sides, and then divide both sides by 4. They get 5 equals x. All right? This is the Pythagorean theorem about as hard as we can do it. Okay? Make it as difficult as you can. All right? Without radicals, I should say. Right. Find the value of x. Give your answer in simplest radical form. What is the first step? When I got a Pythagorean theorem. Find the hypotenuse. It's going to become, by this time tomorrow, you'll know. If you have a right triangle, identify the hypotenuse. Okay? That's just the first thing you do. I don't care how old you are. When you're 46, and somebody gives you a right triangle, you're going to be able to find the hypotenuse. Because that's going to happen. Don't worry about that, okay? Just so you know, that's what's going to happen, all right? So, right here, I start with the right angle. I go across. X plus 4 becomes my hypotenuse. The other two sides, here's a leg, here's a leg. All right. So anyway, once we've identified the hypotenuse, we can plug in the Pythagorean theorem here, okay? The hypotenuse is located across from the right angle. So, once I've got my expression set up in the sides, I just plug in the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. In this case, it would be x squared plus 12 squared equals x plus 4 squared. You'd use the same FOIL or box method that we just talked about on the prior problem. You get this expression, x squared plus 8x plus 16. And then you're just going to solve for x, guys. Subtract x squared from both sides. Subtract 16 from both sides. 128 equals 8x. Divide both sides by 8. Yeehaw! We're there, okay? All right. We now have something that we call a Pythagorean triple. I want you to write this down, okay? A set of three non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared, is called a Pythagorean triple. Right? In this case, if I used 3, 4, and 5 for a, b, and c, I would get 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, 5 squared is 25. 9 plus 16 equals 25, so that's why we call it a Pythagorean triple. They are non-zero whole numbers that satisfy the Pythagorean theorem. Another common example of Pythagorean triples would be 5, 12, and 13. 5 squared, 25, plus 12 squared, 144, equals 13 squared, 169. 25 plus 144 equals 169. Okay, so we call those Pythagorean triples. And the reason I want you to write them down and maybe kind of know them is because if you start seeing 3, 4, 5 or 4, 5 in sides of triangles, you should be thinking, oh, whoa, 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 this looks like a Pythagorean triple. 3, 4, 5, 30, 40, 50, 300, 400, 500. 5, 12, 13. Same thing. Okay? Right? So Pythagorean triples. They's the thing. Now you guys are going to try one, okay? Alright. I want you to find the missing side of this triangle. I want you to tell me if this is or is not a Pythagorean triple. Okay? One thing, I'm going to go back, so just give me a second. One thing I failed to mention about Pythagorean triples. A, 3 non-zero whole numbers. So non-zero means it's not 0. Okay? 0 won't count. Whole numbers indicate there are no decimals involved. Okay? Whole numbers, guys. A whole number. Counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up about as high as we can go. All right? Non-zero whole numbers. Don't mess this up. All right, guys. Go ahead. I'll give you 3 minutes to do this. My first step in every Pythagorean theorem, every right triangle problem is to do what? Find the hypotenuse, which we all know how to do by locating the right angle and going across to the other side. Okay, so this side is the hypotenuse. I will then plug in the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Okay? Yes, it has to be written in the right order. Yes, I will count off if you don't write it in the right order. That's like getting it wrong. Okay? It has to be written that way. 14 squared is 196. What's 48 squared? 2304. 2304 equals x squared. When I add these together, get 2500. All right. Mr.
Estebanco.
You never call an Estebanco.
Why call him me?
It's never called.
Mr. Keaton. It is Randy. I just felt like calling him Randy, or Mr. Keith today. I almost called him Mr. Randy. Alright, Mr. Randy. How do I get rid of this exponent to solve for x?
Why did this look funny
We're waiting, Mr. Randy.
We wait a little bit. What does
Randy's perfect. I square root both sides. And when I take the square root of 2,500, I should get 50. Alright, everybody do this, please. Everybody raise your right hand. It could be your left hand, but raise your right hand, okay? Raise your right hand and repeat after me. I, state your name,
Jamie Balloon.
will no longer divide both sides of an equation by 2 whenever I have an exponent of 2. So help me God. Alright, thank you. You have now sworn it to me that you will no longer divide both sides by 2. You now know that you have to square root both sides. Okay? If you divided both sides by 2, you have not fulfilled your mathematical obligations that you've sworn to protect. Alright.
Can you start taking on that side?
Sure, Paige. I'll just block Justin. No problem. Alright? The converse of the Pythagorean theorem gives you a way to tell if a triangle is a right triangle when you know the side lengths. You don't have to write this down, but you should listen to me. Basically, what this says is, if I plug in the Pythagorean theorem for a triangle, and it is true, meaning that a squared plus b squared equals c squared, okay, that means that I have a right triangle, okay? If the Pythagorean theorem is true, you've got a right triangle. The reason we study this is because if, when I plug in the Pythagorean theorem, if the longest side squared is bigger than the sum of the legs squared, then I have what is called an obtuse triangle. Y'all should probably write this down. And if, when I plug in the Pythagorean theorem, if the longest side squared is less than the sum of the squares of the legs, then I have an acute triangle. Alright.
What is it?
Which one does
Hey, check it out. This is the summary of what I've just been saying. If c squared equals a squared plus b squared, aka if hypotenuse squared equals leg squared plus leg squared, then my triangle is a right triangle, which means the Pythagorean theorem must be true. If it's off by 1 eensy beensy bit, okay, like 0.00001, got me? If it's off at all, that means I've got an acute or an obtuse triangle. Simple enough, right? Could have equilateral, but those are going to be easier to recognize because they have equal sides. Okay? But just so you know, if the longest side squared is bigger than the sum of the legs squared, you have an obtuse triangle, which means that in this case, this is angle C. It means that angle C has to be bigger than 90 degrees. Otherwise, you would have an acute triangle, which means that angle C must be less than 90 degrees. What's up, dog? Oh, yeah, you could just look at it because you're really good at knowing the difference between a 90-degree angle and a 91-degree angle, right? No, you got to do the math. Okay? Fair point? Fair point. The point of this is, hey, quit telling Laffy Taffy jokes. The point of this is this. You can use your Pythagorean theorem to determine if you have a right triangle or if you have an acute or obtuse triangle. Okay? That's the point of today's lesson. Let's see how good you guys are at this. I'll give you 5 minutes 5 minutes to do these two problems, okay? Yes, you must do them. It is part of your classwork. So, how do I identify... bad question. Jamie, what is the hypotenuse here?
X plus 3.
X plus 3. Very good, okay? X plus 3 is the hypotenuse, which means that X and 9 are the legs. Jamie, put that into the Pythagorean theorem for me.
9 squared plus x squared equals x plus 3 squared.
Okay, very good. 9 squared plus x squared equals x plus 3 squared. Let's simplify what we can. 9 squared would be what? 81.
81.
Plus x squared equals, ooh. No. What do I do now?
9.
Give that box.
What do I do now? How do I square this? Do what? Okay. Now what do I do with that?
I don't know. You put it that way.
Put it in my calculator.
You get
4.
9.
How about you know?
Foil.
Yeah, it's you foil or you box. You foil or you box. Last time I foiled, today I'll box. X and 3, X and 3. Faith Miller, what's X times X? What is X times X? What is it? X times X.
It's squared.
X squared. Oh, I'm sorry, Beth. What's X times 3? 3X. Okay. 3X. 3 times 3. Good. Glad we're all there.
That is what messed
Oh,
up.
Blue, your turn. Combine these terms for me. What do I get?
6x.
Good.
X squared.
Okay.
9.
So it's going to be x squared plus 6x plus 9. Okay?
That is one messed up, baby.
That is definitely one messed up little band right there. Now, I'll rewrite this for clarity's sake. 81 plus x squared equals x squared plus 6x plus 9, correct?
Mm-hmm.
All right, Jamie, I'm solving for x, right? Help me out. What do I do?
Well,
No.
I've combined all the like terms I can.
Correct.
What do I do now?
oh, never mind.
Legislate.
You can. We'll fail you and see you next year.
I don't want to see you next year.
Okay, your choices.
Minus 6 squared.
I subtract x squared from both sides. That would eliminate x squared. What else do I do?
Subtract 9.
Subtract 9 from both sides. I get 72 equals 6x. Jamie. 72 equals 6x. What do I do to both sides?
Divide. Square root.
You divide.
What? You just.
Why do you not have to square root?
You don't have to square
I don't have an exponent.
X.
If I don't have an exponent, do a simple one-step equation and get 12. Is that my final answer?
No. You gotta plug it in.
How about read the directions?
Yes, that is it.
That's all I gotta have right there, okay?
Mm-hmm. You're
Right? 9, 12, 15, by the way, was one of the Pythagorean triples. Okay, never mind. Alright, Leffler, your turn. Entertainment center is 52 inches wide, 40 inches high. Will a TV with a 60-inch diagonal fit in it? What you gonna do? Draw my picture. Here we go. Is that how your TV stands look? No. What else? Like full rectangles?
Yeah, mine's on my wall.
Oh, okay. So let's just pretend like it was back in the day when we had TV stands, right? All right. Here's 52. Here is 40. What is the diagonal?
Yeah.
No. Tell me how I find the diagonal. What's the diagonal? Do what? Very good. The diagonal is going to end up being a hypotenuse here, right? Okay. Plug in the Pythagorean theorem. I get 40 squared plus 52 squared equals x squared.
4304.
What is that?
4304.
4304.
Then you do the square root, which you get 4
Perfect.
square root 269.
What is it?
4 square root 269.
What is that as a decimal?
Oh, hang on. Stop. 36.11.
Whoa, we did something wrong here.
I get 65.60.
Alright, hold on. Tell me what 40 squared
40 squared plus 52 squared, I'm getting 4304. Square root of 4304 is 65.6, right? Okay. So 4304 x squared, square root both sides, 65.6. Now, this was mind-blowing to some people. Will a TV that is 60 inches in diagonal fit into a hole that is 65.6 inches big?
Yes.
Of course, okay? Yes, it will. So can I buy this 60-inch TV?
Yes.
Alright, very, very good.